Here we have the 2015 question 3. This is junior cert ordinary level, and this is a question on trigonometry. So the first part, it says calculate the size of the angle marked P in the right angle triangle below. So what we know is that, we're just given angles and we're not given any of the sides, but we know that all the angles in a triangle add up to 180. So when they have, say, like an L, that means that it's a right angle. So right angles are 90 degrees. So whatever so 90 plus 22 plus whatever P is has to add up to 180. So 90 plus 22 plus whatever P is, we'll just write it as P for now, has to equal 180. And if we put 90 and 22 together, we get 112 plus P is equal to 180. So P is going to have to be 180 minus 112. So if we get 180 minus 112, we get that P is equal to 68 degrees. So that is the size of P. And then we are given we're given a line. So I don't have a graph paper at the moment, but we'll do our best to get it as accurate as possible. So we're told to draw the image of the triangle under axial symmetry in the line K. So axial symmetry is literally kind of like a mirror reflection. So if I was to draw this under axial symmetry, whatever distance I had to go in there, it's going to be the same distance I have to go out. And then, so it's literally going to be like a reflection. So if it's going to be like a reflection, it's going to look something like this. So that would be axial symmetry through the line K. And then the next part C, so we are given another triangle. So sorry, my diagram isn't the best. So this is, I'll just draw it a bit better. So this is our another right angle triangle, so or 12, 5 and 12. So write down the side of the length opposite the angle or. So if we are looking now, so all the time when we think of hypotenuse, adjacent and opposite, we have to think of in terms of what angle we're dealing with. So in terms of or, so firstly I would label my hypotenuse. So the hypotenuse is the longest side, it's the one opposite the right angle. So this here is going to be my hypotenuse. The opposite, usually we deal with this angle here, but in this case we're dealing with this angle. So we have to look at what side is opposite the angle we're dealing with, to or. Well, that's 12. So 12 is going to be the opposite. And in this case, 5 is going to be the adjacent. So if we want to get the side of the length opposite or, well, it's going to be 12. 12 is the opposite. And then we're asked to use the theorem of Pythagoras to find the length of the hypotenuse of this triangle. So the theorem of Pythagoras is actually in our log tables, but I would recommend knowing it as well. So the theorem of Pythagoras states that whatever the hypotenuse is squared, that's equal to the sum of the square of the other two sides. So say if we have a triangle like this, let's call this A, B, C. So A is my hypotenuse, so whatever A is, A squared is equal to B squared plus C squared. So my hypotenuse, we don't know what it is yet, so I might just call it x. So x squared is equal to 5 squared plus 12 squared. So now I'm just going to work each of them out. So x squared is equal to, so I'm just going to get what 5 squared is. So 5 squared gives me 25, and then 12 squared is 144. So maybe if I add up everything that's on the one side first, so x squared is equal to 169. So if I want to get what x is, I have to get the square root of both sides, because if I get the square root of this, I'll just be left with x. So the square root of both sides, so x is equal to the square root of 169. So if I get the square root of 169, I get that x is equal to 13. So the hypotenuse of this triangle is going to be equal to 13. And that is our answer for that. Thanks for watching.